the given equation has two distinct real solutions. If the difference between the solutions is 3, what is the value of k? We can let the numbers a and b be the solutions, where the difference between a and b is 3. We can start by setting the left side of the equation equal to y. Then, the x values that make y equal to 0 will be x-intercepts on the graph. For a quadratic in standard form, the constant will be the y-intercept. Since a and b are distinct real solutions, x values that make y equal to 0, they will show up as x-intercepts on the graph, and we also know that they need to be 3 units apart. Since the leading coefficient is a positive 2, that means the parabola will open upwards. To solve for x, we could use completing the square or quadratic formula. I'll do completing the square here. Start by moving the constant to the right side of the equation, so minus k from both sides. Then we need to factor the 2 out of the terms on the left side. Be sure to leave a blank space for the constant in the parentheses. Leave the 2 in front of the parentheses, then take the coefficient in front of x and divide it by 2. 7/2 divided by 2 is the same as 7/2 times 1/2. Then to multiply fractions, multiply straight across. Now we'll need to take the negative 7/4 and square it. When we add 49 over 16 here, we're really adding 2 times 49 over 16. We need to balance this out by adding the same thing to the right side of the equation. So we'll add 49 over 8, which is equal to 2 times 49 over 16. Divide both sides by 2, which is the same as multiplying by 1/2. Then we'll need to cancel the square by taking the square root of both sides. Then add 7/4 to both sides. Plus or minus the root means we have two solutions for x. One that uses plus and one that uses minus. Remember that we're using a and b to represent our solutions for x. We can plug a in place of x for one solution, and b in place of x for the other solution. Remember that the axis of symmetry for the parabola is represented by x equals negative b over 2a. Each solution, a and b, will be on opposite sides of the axis of symmetry, the same distance away from it in either direction, left and right. Remember that on our graph, a and b will represent x-intercepts, and the distance from a to b is 3, so that means that a and b will each be 1.5 units away from the axis of symmetry in either, since 1.5 is half of 3. The axis of symmetry is at x equals 1.75, so that means we need to take 1.75 and add and subtract 1.5 from it to get a and b. I've crossed this out here, but don't cross it out yet because we still need it. We're just adding and subtracting 1.5 from 1.75 to get a and b. Remember, these will show up as x-intercepts on the graph. I placed b between 2 and 3, but it should be to the right of 3, and since a is 0.25, it should be closer to 0. Don't forget to like and subscribe. Now that we have values for a and b, we can use one of them to solve for k. We've plugged 3.25 in place of b, then subtract 7/4 from both sides. Square both sides to cancel the square root. Multiply both sides by 2 to cancel the 1/2. Then subtract 49/8 from both sides. Multiply both sides by -1 to cancel the negative in front of k. Now we just need a common denominator to subtract the fractions. Multiply the numerator and denominator by 4 to get an equivalent fraction. The denominator will stay as 8, and then combine the numerators. To get k equals 13/8.